Last time we taught a translator to turn one language into another, sec to sec, then a full transformer learning English to French from nothing but paired sentences. And here's the thing nobody said out loud. Every single NLP model we've built in this course learned language from scratch, embeddings from scratch, grammar from scratch. 25,000 reviews just so the model could figure out that terrible is bad. That's the stage we're standing on today. Build and train. But this time we don't start from zero. We reuse. We take a model that already read half the internet and we just nudge it toward our task. This is fine tuning and it changes everything. Think about what we've been doing. Every model started life knowing nothing. We fed it our little dataset and asked it to learn the entire English language and our specific task, both at once, from a few thousand examples. That's like teaching someone to read and reviewing their book report in the same afternoon. It works, barely, and it's enormously wasteful. Transfer learning fixes this. We saw it in Vision. Take a network trained on millions of images, keep everything it learned about edges and shapes, and just retrain the last layer for cats versus dogs. NLP has its own version, and it's even more powerful. Pre-train once on the whole internet. Fine-tune on you. The pre-trained model here is BERT, and the clever part is how it learned. BERT read billions of words, Wikipedia, books, the open web, and played a game called Masked Language Modeling. Hide a word, guess it from both sides. The cat sat on the blank. Matt, do that a few billion times and something remarkable happens. It learns language itself, not your task. Language, grammar, so it knows masterclass is a noun. Facts, so it knows Paris is a city. Word relationships, so it knows tense and gripping live near each other. All of that is baked into its weights before it has ever seen a single one of your examples. So fine-tuning is almost embarrassingly simple. You take that giant pre-trained body, you bolt a tiny classification head on top, just a small dense layer that maps BERT's understanding to positive or negative. And you train the whole thing with a very small learning rate. Tiny, because you're not teaching it language, you're just gently steering knowledge it already has. And you don't touch the tokenizer at all. Remember all that work in earlier episodes, building a vocabulary, mapping words to integers, padding sequences. The preset bundles its own preprocessor. Word piece tokenization, the exact vocabulary BERT was trained with, weights, config, all in one download. You hand it raw strings, it handles the rest. Here's the payoff. Our from-scratch transformer needed 25,000 reviews to hit 90%. Fine-tuned BERT on 2000, 1/12 the data, gets 93. Less data, higher score, because the pre-training did the heavy lifting. You're not paying to learn English anymore. You're only paying for the last little bit that's specific to you. And this is the modern default. In the real world, almost nobody trains a language model from zero. It costs millions of dollars and oceans of text. You adapt a foundation model. You start from something that already knows the world, and you specialize it. Once you see this, you'll never go back. Let's build it. Then next time, we'll push the same idea further, pulling named entities out of text and answering questions about it. Here's the whole file, and it's shockingly short. 3 quick pages, that's the point. Almost everything that used to be our code now lives inside the preset. Load the data, load the model, compile, fit, evaluate, predict, save. Let's walk it. Imports, TensorFlow and Keras as always, plus Keras Hub. That's the library formerly known as Keras NLP, where all the pre-trained presets live. We also pull in TensorFlow datasets, so we can grab IMDb in 2 lines instead of downloading and unzipping by hand. The data, we load IMDb reviews through TFTs, and here's the deliberate move. We take just the first 2000 training examples with our take 2000. We're proving a point about data efficiency, so we're starving the model on purpose. We batch both splits and notice what's missing. No text vectorization layer, no manual vocabulary, no padding. The strings stay as raw text because the model's own preprocessor wants them that way. And here's the whole reason we're here. One line, BERT text classifier dot from preset. We name the preset BERT bus and uncased. Say we want 2 output classes and that's it. Behind that single call, BERT's pre-trained weights, download and load, the word piece tokenizer attaches, and a fresh classification head gets wired on top, ready to train. The thing we spent 6 episodes building by hand is now a function argument. Compile. The only number that really matters here is the learning rate, 5e5, absurdly small compared to the 1e3 we'd use from scratch. That's the gentle steering rule in code. The body already knows language, so we tap it lightly instead of shoving it. Sparse categorical cross entropy, because our labels are plain integers, 0 or 1, and from logits a true because the classifier head hands us raw logits, not probabilities. Accuracy as our metric. Fit 3 epochs, just 3 on 2000 examples, and you'll see in a second that's already enough to beat the from scratch model. We pass the raw text dataset straight in. The bundled preprocessor tokenizes every batch on the fly. No preprocessing step in our code at all. Evaluate on the full untouched test set, 25,000 reviews the model has never seen, and print the accuracy. This is the honest number, the one that goes in the figure. And the fun part, predict. We hand it 2 raw sentences it's never seen. Model, predict returns logits, so we softmax them into probabilities and argmax for the label. A masterclass intention comes back positive at 98% confidence. It nailed a sentence that wasn't in any training set because it actually understands the words. Finally, model.save. The entire thing, fine-tuned BERT, the preprocessor, the head, saved as one Keras model you can reload and serve. And that closes the loop on our whole pipeline. Next episode, we keep reusing pre-trained transformers, but for 2 new jobs, finding the entities inside text, names, places, dates, and answering questions about a passage. NIR and QA, see you there.